Hi YouTube, and welcome to the Iknow channel. Today we're going to be building our very first operating system just from scratch. I'm going to be doing this under Linux because it's much easier. So even if you do not have Linux, I suggest you install it. Even if you do not want to say goodbye to Windows, you can install Linux on a virtual machine or in a dual boot. So the choice is yours. But I suggest you follow the tutorial on Linux. Okay? So the development is gonna be with the C programming language and a little bit of assembly. Even if you do not know how to program with assembly, I'm gonna try to simplify as much as I could. And so this is gonna be the first episode. And after this episode we're going to be presenting new other episodes 2 and 3 and etc. And see you later. I mean, let's get started. So, welcome again to the first episode in operating system development. First thing you want to do is to set up your development environment, which means you have to install the required packages in your Linux distro. So first thing, create a new document and then call it setup.h or whatever you want to call it. I already created it, so there's no need to do that again. So I'm going to be calling it s.sh and open it, and then it is what you have to type inside it. So this entire code, copy it into the s.sh file that you have created right now. So what this is gonna do is gonna be install all the needed tools automatically. So it's gonna install roxxiso and grub, which are gonna help us later to build the bootloader and the ISO image of our operating system. The GCC, which allow us to compile the C code, NASM, which allow us to compile the ASM, the assembly code or the entry point of the kernel, and VirtualBox, which allow us to test our final version of the operating system, qemu, which allow us to test our operating system, our kernel, very fast without the need of making an ISO image from it, and the gedit is an optional. As I mentioned here, it is a text editor. Actually, this is the gedit. Once we're done doing that, all you gotta do is go to your file and go to properties and permissions and allow executing file as program. This will allow you to execute the code inside that file when you double click it. So when I double click it, run the terminal, just open up. So if I open this file, run the terminal, it's going to execute everything and install everything I need. Everything that we're going to need to build our operating system automatically. So no distraction. After you've done that, I'll create a new folder, call it us, or whatever you want to call it. I want to call it us. So then open it up, and first we're going to be creating all the files needed to build our operating system. Create a new document, call it kernel.asm. This is going to be the entry point of our kernel, and then create another file called kernel.c, and then another file, call it you can call it build.sh, and of course make it executable. Then under properties, go to permission, then allow executing file as a program. Then the next thing you wanna do is, okay, that's pretty much it. You have to create another file called link.ld. We're gonna be discuss this later, but create them for right now, and we're gonna be using them later. So build link.ld. Good. So to start up, we're not gonna be building the bootloader. What the bootloader does is a very short code that is placed in the very first sector of the boot drive, whether it's a flash drive or a disk or whatever. That little code then sends the processor to a specific address to continue executing from it. That specific address is the kernel.asm, which is the entry point of our kernel. Our kernel is, let's say our kernel is our operating system. Okay, the kernel is split in two parts. The first part is the entry point, which must be in a specific address in the memory, and then that entry point will send the execution to the kernel. So it's gonna happen, the bootloader will send the execution to the kernel.asm, and then the kernel entry point, which is the kernel.asm, will send execution to the kernel.c. That's what's gonna happen. But of course, these two files are text files. We're gonna need to write some codes into them and then compile them using the tools that we have installed using the setup.sh. Okay, so let's get started. Open up the kernel.asm and then type in bits 32. This means that our operating system is going to be 32-bit operating system. And then type in sections, and then dot text, and then a line, 4. This means that okay, let me just make this like that. Okay, means 4 bytes, since 32-bit equals to 4 byte. Of course, the code that I'm going to be writing it under sections, you do not have to understand it right now, since it is a very low level details treated by the bootloader. You don't have to understand it right now, but I'm going to be explaining everything later. Then define a double O x1 b and d b 0, 0, 2, and then define double O x 0, 0, and then define another double, we'll type in minus, and open and close parentheses, and then the two values are going to be values. So, of course, as I mentioned, you do not need to understand these, what this means. It's going to be treated by the linker. You do not need to understand that right now. All you want to understand is that this is the magic number, the number that the bootloader must find to recognize that this operating system is a multi-boot operating system, which means it has the capability to boot it up. So, first thing we want to create is a function called start. Type in global start, and we type in global so that this function we can access using a linker. Then type in extern, and then payment, and then start, and then CLI call qemu, and then HLT. So here is the start function that we are going to be start executing it with the linker when we link the two objects together. We're going to be discuss this later. Here we are creating a new external function called qemu, which is going to be in our C code. So this function is going to be located in our C code. Kernel.c. And the start function here is the computer will start executing this function. Of course, I'm gonna be explaining this later. Okay. And the CLI, what the CLI means, it actually means clear interrupts. So this clears the interrupts. The interrupts are, let's say that the interrupts are some services provided by the BIOS to do some basic stuff like writing some things to the screen and taking some values using the keyboards and stuff like that. Since we moved to the 32-bit mode, or it's also called the protected mode, we can no longer use those services. So what we want to do is to clear the interrupts since we're not going to be using them, and free up some spaces for the C to be used by the C code. And here the call qemu, this function actually calls the kernel. The kmain function is going to be in the kernel.c. So send processor to continue execution from the kmain function in C code. And the HLT actually means held the CPU, so held the CPU, which means pause it from executing from this address. Okay, and this semicolon actually means that what we're going to be writing after it is a comment. It's not going to be compiled. Okay, so after writing this code, all we want to do is to save it. So this is the entry point of our kernel. Save it, and then open up the kernel.c. Okay, I want them to open the same window. Okay. So this is the kernel.asm and this is the kernel.c. So what's going to be inside the kernel.c actually is the kmain function. That's it. So kmain, and that's it. The kmain, we noticed that we did not use any keyword like void or int or whatever the type it is, because this function is already defined in this in the asm function. So kmain, this function is going to be located in C. Okay, so this we defined it here. So this code is a fully working code, but of course it's going to be doing nothing since we did not write any code inside the kmain function. So to demonstrate that this is working, I'm gonna print a character to the screen. Of course, I'm not gonna be explaining why it is happening right now, since our goal is to demonstrate how these things are working, how to compile, how to make something working. Later I'm going to be explaining stuff in C and how to write to the screen and how to read from the keyboard and stuff like that. So again, you don't have to understand what I'm going to be typing right now. So I'm going to type char pointer and vidmem, a pointer variable called vidmem is gonna take the value of x v8000 and semicolon, and this value we're gonna be casting it to a char. Okay, so after that, then this vidmem, the vidmem of 0 is gonna take the letter A, and vidmem of 1 is gonna take OX07, which is the color of the character. OX07 actually stands for a gray color. So that's it. Then save the code. Now we have a fully working operating system that boots up and prints the character A to the screen. Now how to compile this thing? To compile this project, we have first to compile this ASM code, which is the entry point of our kernel, and then to compile the kernel.c code, which then will start executed, which will take execution from this file. And then after compiling these two files, we're gonna be combining them together, combining the resulting of them together to build one final binary executable format file. So to compile them, simply go to the folder where your files are located, and then open a new terminal. You notice that the terminal is located in that folder, so that's /os, which is our folder here. And to build the kernel.asm file, all we want to do is to type in nasm and then -f and then elf32. This means that the output format is going to be an ELF file, 32-bit mode, and then the input file, which is kernel.asm, and then -o, and the output file, which is kasm.o. So we're going to be outputting a file called kasm.o. So press enter. You notice that the new file called kasm.o had been created here in the same folder. Now the second thing is we want to compile the kernel.c. We do that by typing gcc space -m32 space -c, then kernel.c file, which is going to be the input, and -o and kc.o, which is the output. So this is going to be taking the kernel.c file and then outputting it in the name of kc.o, and of course going to make the resulting file a 32-bit mode. So then press enter. New file called kc.o has been created. Now we have two binary files, but how to link them together? And of course to make the entry point, which is the kasm.o, the first file. So to do that, we need the linker. We open up the linker, and you notice that we have wrote down nothing to the linker. So of course I'm going to be going to the linker file that I have created here and copy the code from it and paste it to my file, which tells here that the output format is going to be an ELF file of 32-bit mode, and here we specify the architecture of our computer. Usually put i386, even if your computer is 500 or 600, no matter, just enter this value, and then the entry start here. The entry point is going to be start. Okay, this is the entry point that we have talked about before in the kernel.asm. here it is. We said that this is a global start. So what the linker is going to do is going to search for a function called start. It's going to look here. No, there is no function called start. It's going to look here. Okay, there is a function called start. It's going to start execution from it. And then when you start the execution, the start function is defined here. So what it's going to do actually, it's going to jump to this place and then start reading these functions. So first it's going to clear the interrupt, and then it's going to call the key main, and then if the processor when the processor finish it reading what is inside this key main, it's going to go back, of course, but we do not want it to continue executing, so it's going to halt the processor. We're going to stop the processor from continue executing, or it might be executing some garbages on the memory that might damage our system. So of course we want to pause it. So, and the sections here are the notice that the .text section here is what we defined here, which is the .text. So it's gonna be making the linker according to our choices here. This is where we want our code, the very first byte or bit of code. Where do we want it to be stored in the memory? We want it to be stored in this address, which is 100,000 hexadecimal, which is the very first place for our kernel. If you go to Wikipedia, you're gonna find that the available memory for the user to locate his operating system into is this address. So you don't have to care about these because we're gonna be explaining them later when you need to. And then after you're done, hit save. And then to compile, to link these two files together with the aid of a linker file that we have created here, all we gotta do is to type in ld, which stands for linker dash m space elf, and then underscore i386 space dash t space link dot ld space dash o space kernel dot bin, which is the output file, and then kasm dot o, which is the first input file, and kc dot o, which is the second input file. And make sure to put the kasm.o first, so it's gonna be linked first. If you reverse the order, of course that's not gonna work. Then press enter. Wow, voila! So we have successfully compiled our kernel.bin. To test it out, we have to use qemu. So of course you have installed qemu. I'll assume that we have installed qemu. So okay. So to test your kernel.bin, type in qemu space dash kernel space kernel.bin, which is your file, and then press enter. You notice that it works. So it printed the character A to the screen. Of course it did not delete, it have not deleted all the extra text on the screen because we did not ask it to do that, but at least it replaced what is inside that character with the character A. If we change it, for example, to X, it's gonna be X in this place. Okay, and okay, so close. But of course, you notice it that if we want to compile our kernel, we have to retype all of these codes again, which is a totally pain. So that's why I have created a build.sh file to make all of these codes happens automatically. So open the build.sh and simply retype all of these codes here. So like that, so I can see. So nasm space dash f space elf. Let me copy and paste. That's gonna be easier. So copy and then copy the second one. And then third line of code. Okay, and then the qemu kernel.bin. So this will execute it automatically. Will execute all of these codes automatically. So close this terminal and save. Now make sure that it is executable. Go to it and type in, choose properties, go to permissions and allow executing file as program. And after that, all we want to do is to make our changes. So go to kernel.c, and then this is the letter A. I'm going to be changing to X, for example, and I'm going to be changing the color to, let's make it green. I guess 2 is for green, so save. And build sh, run the terminal, so it run automatically. And you notice that the first character is changed to green X as we want it, and the entire code had been executed automatically. So voila. Now what if we wanna convert this kernel.bin into an ISO image, which could be which we can run in VirtualBox, or we can burn into a CD or DVD or flash drive or whatever it is. Okay, so to create the ISO image, first create a new folder, call it whatever you want to call it. I'm going to be calling it os, or let's say Iknow. Inside it, create a new folder, call it boot, and inside it another folder, call it graph, and inside it a new file called graph.cfg. Okay, open it up, and then basically I have already created it here. So all we want to do is to copy the content of this file from here and save it. What it's gonna do here is to set it to default. So it's gonna run it by default, this operating system, and the timeout, it waits for 0 seconds in order to boot your operating system. So it's gonna boot it directly without choosing or switching to another operating system. And here we've got a menu entry, which is one entry which is called Iknow, and the kernel.bin is located under root folder. So save, and under boot folder, I mean here, we have to add our kernel.bin. So go back to os and copy the kernel.bin, copy it, and under the boot folder and copy it here. You can choose whatever you wanna, wherever you wanna put your kernel.bin. The main thing is to change its location here from within the graph.cfg file. Then once you successfully done that, open a new terminal, of course from within your main directory folder, and then type in grab-mk rescue space -o and then the name of your output file .iso, and the directory, which is Iknow directory. So Iknow/. And press enter. It tells you enabling iOS support, xorriso, stuff like that. Then, okay, we successfully created the Iknow .iso image. I'm going to be closing this, and I'm going to be opening VirtualBox. VirtualBox. I don't know where VirtualBox is in here. Whatever. Open a new terminal and type in VirtualBox. And just ignore these checks and create a new virtual machine. Name it whatever you want. I'm going to be naming it test my OS, for example, and choose other and other. No, I'm going to change it to my OS. Then next, and do not add a virtual hard drive. And then press create, continue, and then we have created our virtual machine image. To load the ISO, simply select your virtual machine and go to settings and storage. Under this disk label here, choose a virtual CD disk file, and then browse to a folder under OS ISO, then open it up, press OK, and start up your machine. Voila! Notice that we have successfully booted into our operating system. This text here is generated by grep, but later we're going to be create a new function that will clear the entire screen and then print up whatever we want to print. So this text won't be visible anymore later. So thank you guys for watching. If you followed with me this tutorial, then oh, wait a second. First, I'm gonna go to the build.sh and display, and I'm gonna add the code that creates the ISO image, so that's gonna be recreated automatically for me whenever I compile the code. So type in grep -mk rescue space -o space iknow space .iso space the folder, then /, and then hit save. But from a personal perspective, I do not want to recompile this code, recreate this ISO image whenever I recompile the code. So you can deactivate the execution of one line of code by adding this mark here. So by adding this mark here for this, and for this, for example, when you rebuild, it's gonna only execute this line of code, and then this line of code, and then this line of code only. When I make a change in the entry point, which is the kernel.ism, I can just delete this mark here, and it's gonna work very well. Okay, then save our code here. Okay, I'm gonna delete this for now, and I'm gonna be deleting the ISO image. And when I start the build.sh, you notice that the code had been compiled successfully, and qemu had started the project for me and printed out that X letter there, and also the iknow.iso had been created for me. So that's totally great. But we've got a problem here. The problem is that the kernel.bin that is generated in this folder, but we want it to be generated in this folder. So what we're gonna do, simply we're gonna go to the build.sh file and change the output here, which is output.bin, kernel.bin. We want it to be in folder Iknow / boot. So under Iknow boot, our kernel.bin is going to be here. So save, quit. I'm going to be deleting this one, for instance, and this one, for instance. And of course, by changing the output location, we want to change the reading location of query. It's going to be reading from the folder Iknow / kernel.bin. Okay, we're good to go. So if I, for example, go to kernel.c and change the character one other time, so I'm going to be changing it to Y and change the color to red, and then save, and then close this file and recompile my file again, you notice that that changed to Y in the red. So what if I want to be printing two characters here, so a character and a character? Okay, actually I should show you this in the next video, but let me just show you a little bit from it. So I simply copy this code here, and this, since we ended with 1, this is going to be 2, and this is going to be 3. And then here I'm going to be changing the letter to, for example, K, or let's change this to H, this to L, choose the, or to E, for example, for the hello. Okay, and this to 3. Now save our code, and then start the build.sh, and you notice that HE for the hello. Okay, so it's pretty much working. So I'm gonna be showing you how to make a function that would make this easier for you. We're gonna be creating the function printf, which will allow you to print an entire text to the screen in the location that you want, and we're gonna be controlling the cursor, and we're gonna be reading values from the keyboard and stuff like that. And so see you in the next tutorial. Thank you guys for watching. You've been with Nigar Labidi in the first episode of the operating system developments. If you have any question, any suggestion, feel free to leave a comment in the comment section below. Also, don't forget to like, share, and subscribe, because that's gonna support me a lot. Thank you guys for watching, and see you later in the next tutorial.